We'll have a look at a problem where we observed and obtained a sextant altitude of the sun's upper limb on the meridian when it was south of the observer. We're given our dr longitude, index error and height of I. So first of all we have to calculate the GMT and LMT of meridian passage, and then we have to find the observer's latitude. So let's have a look at how you calculate a GMT and LMT of meridian passage. What we need to do is get our GHA. Now as the longitude is west, we add it to an LHA value of 0. Had our longitude been east, we'd have subtracted it from 360. So remember that at the meridian, the LHA has to be either 0 or 360. So that gives us our GHA of 14622.4. We now enter the almanac on the 29th of April and find the nearest GHA value to our GHA 14622.4. So we go into the 29th and we have to go down and have a look and see the nearest value. Okay, so we write that down. Then we would subtract that value from the original 146, and that leaves us with increments of 10 degrees 41.3. So now we go into the increments section and find 10 degrees 41.3, and that gives us 42 minutes 45 seconds. So our GMT is the 29th, 21, 42, 45. Okay, so get GHA, go into the tables, look up the nearest hour, the balance that's left will be looked up in the increments, and now we've got the GMT of Merpass. Well, what about the LMT? Well, the LMT is the local time, so we simply apply our longitude to the GMT, and that gives us our LMT of Merpass. And incidentally, if you were to look in the tables on the 29th, at the bottom right, you'll see Merpass of the sun, and you'll see that it's 11:57. So 29th, 11:57, but if you're asked to calculate it, then that's the correct procedure to use. Okay, now what about getting the latitude? Well, to get the latitude, we'll need our declination. So as we've got our GMT of Merpass, we'll look up our declination, and I've written it there, and our declination is north. Then we calculate the true altitude. So we're given the sextant altitude of the sun on the meridian. So there's our sextant altitude, and our true altitude, subtract from 90. And as it tells us that it's south of the observer, we write the true altitude south. Once we subtract from 90, the true zenith distance has to be north. So notice we change, it changes from south to north, 14 degrees 15.7. As our declination is north, we add the two together, and that will give us our latitude. So as it says here, as the sun was south of the observer, after subtracting from 90, we change the sign to north. Now we apply the declination and add because they're both named the same. So that's how we get the latitude when the sun is on the meridian south of the observer and we have a northerly declination.